Hello, this is Michael Burke, your instructor for Math 220, algebra, college algebra. We're going to start by doing a quick intro to the course, and then followed by doing some information on a PowerPoint presentation that I'll give you for the class. I'm going to try and keep this to about an hour, because I want you to get started on your assignments. First off, you'll find that we have a textbook online. You can find it in Course Home, Algebra 1 for the community college and Algebra 2 for the community college. Your assignments and readings come out of there. We will be meeting in LC5 from 8:30 to 12:30 on Monday and Wednesday. We will be doing all sorts of things in class, including some in-class exercises that you will not be able to make up if you miss class. So you need to be in every class. In the first week, we're going to be doing we're going to be discussing the order of operations. That's what the thing that I'll be doing today. You'll see in readings and tools, you'll find a link to some extra videos and so forth from Khan Academy. I urge you to look at them. Also, in the first week, we have a discussion. The discussion has a series of problems. You will find that the problems are in several groups. You'll do 2 problems in each group. And one of the groups has only 3. Mostly, I'm going to tell you that you will not do the same problem. Multiple students will not do the same problem. Group 2, unfortunately, is a little different. We'll just have to waive that rule. But what you do before you post is take a look at what your fellow students have done. What I'd like you to do, if you don't have time to do a post immediately, claim some of the problems. Just put down the number, post once, put down the number, then you'll be able to claim those problems. But do not duplicate a problem from another student. That's the discussion. The usual rules. Principal posting will be due by Wednesday night, and 2 replies, responses to other students by Saturday. Your first week assignment, there's a worksheet in assignment 2. Assignment 1 is to make flashcards about the various steps in the order of operation. You also have an assessment. So right now I'm going to go to a PowerPoint. And here it is. Let's make it a presentation. All right. Some definitions. Algebra is just arithmetic with letters. The purpose of algebra is to determine the value of the letters. So a variable is a letter that can have a value. It can be any letter. We often use X and Y, but A, B, C, almost any of them can be done. A numerical expression is an expression, multiplication, subtraction, division, etc., involving only numbers, whereas an algebraic expression will have 1 or more variables. And order of operations is the way we actually solve problems. We'll go through some slides on that in a little bit. We use this acronym PEMDAS, and that really stands for Please Excuse My Dear Aunt Sally. We do operations within parentheses, that's the P. Then we do the exponential terms, that's the E. Then we multiply and divide, that's the MD, and then add and subtract, that's the AS. And we always work from left to right. So we all know various things. We're going to throw a few more. Arithmetic is numerical expression is just addition. And in the vocabulary, the answer is the sum, S-U-M, of the numbers or the variables or a pair. Subtraction also has a name. The answer is the difference. Multiplication can be represented by several different means. A dot, an X. This reads 9 times 8. If you have variables in your equation, we don't use the X. Or 9 parenthesis 8. This means 9 times whatever is inside this parenthesis. We can do the same thing with variables. So the answer of a multiplication activity is product. Division can also be expressed in several different ways. The divide sign, we can express this as a fraction, or we can use the famous handwritten division sign. And of course, the answer is the quotient. So we can do that with all of these. Let's give some examples. Order of operations. Remember, parenthesis, exponents, multiplication, division, addition, subtraction. Here we have only addition and subtraction. So all we do is move one step at a time. Let's back up. So we add 8 plus 7 is 15, subtract 4, 11, plus 12 is 23, minus 7 is 16, plus 14 is 30. Okay, in the example number 2, we have 7 times the contents of these parentheses. As we said before, we do the operation inside the parenthesis first. So we add 9 and 15, or 9 and 5, and get 14, and then we multiply by 7 to get 98. A word, I do a lot of math in my head, check my numbers. I sometimes make mistakes. Over here, it's the same thing. We've got 7 plus 8 in parenthesis divided by. Note, divided by. That means that the second term here is doing the division. Okay, so this would be 7 plus 8 equals 15. And then we do this, 4 minus 1 is 3. And now the answer is 15 divided by 3, or 5. Remember, divided by. Here is a little more complicated equation. Okay, we have 2 parentheticals. 4 plus 2 is 6. 7 minus 1 is 6. Then we multiply them. Okay. Now, let's look down here at this fraction. When you see an expression like this as the denominator of a fraction, it is understood to be in parentheses. So we also simplify this to 7 minus 3 equals 4. So now we have 36 divided by 9 plus 4 divided by 4. So we do the division first. 36 divided by 9 is 4. 4 divided by 4 is 1. So we have 4 plus 1 equals 5. Okay. So what you can do here is we'll just go through a couple of these. Again, remember, do the parenthetical part first. So this is 5 times, and then 3 plus 2 is 5. So this is 5 times 5. Here, again, add these up. We've got 10 times 2 divided by 5, 16 divided by, and remember, this is an implied set of parentheses. So this now becomes 4. So now we have 10 times 2 is 20, plus 16 divided by 4. This is divided by 5. So we have 4 plus 4 is 8. And again, when you just have a series of additions and subtractions, start on the left and do it one step at a time. 10 minus 3 is 7, plus 5 is 12, plus 8 is 20, minus 1 is 19, minus 3 is 16, plus 11 is 27. Now, algebraic expressions are just another way of looking at numbers. The variables have values. Sometimes we're going to be given the value and tell us to solve these expressions. So here we have 3. If we substitute, this is 3 again. If there's nothing here, this implies 3 times x plus 4 times y. So now we have 3 times x is 5, 3 times 5, plus 4 times 3. So we have 15 plus 12 is 27. Same thing down here. We simply put in the values. So this is 2 times 5, and then we add 2 to that product for 12. And then 3 times 5 is 15, minus 3 is 12. So this one's 1. And again, 12 times 5 is 60. Plus 3 times y is 9 for 69. And then xy. So we do the 12 times x, 60. 3 times y, 9. And x times y. Remember, when they're just adjacent, there's an implied multiplication. Okay, so 5 times 3 is 15. So we now have 60. 60 plus 9, 69 plus 15 is 84. Okay, we can do the same thing here. Go ahead and remember, if we were in class, you guys would be solving these. Remember 10 times 2. So the first thing we do is the multiplication, because remember, subtraction comes at the end. So 10 times 2 is 20, minus 7 is 13. Same thing here. We have 2 times x, or 4, plus 8 times y. 8 times 7 is 56, right? So 4, and then over here we have 3 times x, or 6. So we have 4 plus 56 equals 60 over 6. The answer is 10. Now, again, a word about parentheticals. Let's go back up one more. These are considered parentheticals, even though there's no parenthesis shown. In a fraction, when you have more than one term in either the numerator, the top number, or the denominator, the bottom number, we imagine these as being in parentheses and solve these first before doing the final division. Okay, let's go into some more definitions. An integer is a whole number. Okay, that includes negative numbers. They're also called counting numbers. Okay, so that's another one. A prime number is a number that is only divisible by itself and 1. We'll come back to those in a bit. A composite number is all other positive numbers that aren't prime. They are whole numbers, but they are not negatives. Okay. The greatest common factor is the largest whole number that divides both or all of the numbers in question. We have a process for determining that. I'll probably go into that in more detail when we meet on Wednesday. The least common multiple is the smallest non-zero multiple of two numbers. These are definitions. Prime numbers less than 50. Here are all of them. 1 is not considered a prime number. That's a special case. 2 is a prime number, even though it's even. It's the only even prime number. Every even number is divisible by 2, at least 2, and itself. 3, 5, 7, 11. These all do not have any, they have no other factors that can be multiplied to produce them. 13, 17, 19, 23, 29, 31, 37, 41, and 43. So prime or composite? Well, 2, 3, 5, and 7 are all prime. They are on the prime list, but they can only be divided by 1 and themselves. So they're prime. 4, 6, 8, and 10 are all even numbers. Therefore, by definition, they are composite. 22, 33, 44, 55, and 66. First off, a couple of rules. 22, 44, and 66 are even numbers. Therefore, they're composite. 33 and 55 can be divided by 3 or 11, 5 or 11. 22, 44, and 66 can also be divided by 11. They're composite. 29, 31, 37, and 41 are all prime. They're on the list. These numbers are all prime. They're on the list. These numbers are all even. They have to be composite. Okay. Now we go through a process we call prime factorization. Every composite number can be expressed as a product of prime numbers. Now, composite numbers, so that takes out the primes. 4 is 2 times 2. 2 and 2 are primes. 6 is 2 times 3. They're prime numbers. 8, note, we're not limited to 2 factors. 2 times 2 times 2. Let's jump over here to 12. 2 times 3 times 3, or 2 times 2 times 3. 16, 2 times 2 times 2 times 2, and so forth. Okay? So we can have multiple numbers. Now, every number, we said that all even numbers are composite numbers. Any number ending in 0 or 5 is a composite number. Every number ending in 5 is divisible by 5. There are some tips here. If we add up the digits of our number, that is, if the sum of the digits of the number is divisible by 3, then the original number is divisible by 3. Let's back up. Okay. 33 is 3 plus 3 is 6. That's divisible by 3. 6 plus 6 is 12. That's divisible by 3. So if no other test worked, this would be proof that it was indeed composite. Okay, so let's go down here. If it is any number that ends in 0 or 5, 10, 15, 20, 25, they're all divisible by 5. 7 is a little more complicated. It's the last of the single-digit prime numbers. If we take the last digit in our number, double it, and subtract the last digit in your number from the sum of the rest of the digits, if the result is divisible by 7, so is the original number. So let's take as an example, and this is one thing that okay. 112. Okay. Okay. So we have the last digit here is, if we look at the number 112, let's get out of here and go to add a slide. We're just going to insert a new slide in here, and we're going to say our number is 112. Okay. If we look at that, the last digit is 2. If we double that, it's 4. Need to be able to type. And now we look at if we take a look at the sum of the rest of the digits is 2. Okay, they've got this screwed up. We'll address this in class on Wednesday. I'm sorry, that was a mistake on this. On this slide, my apologies. But we can look at the rest of these, okay? And this is only useful if you have very large numbers. And we'll have to think about that for a minute. Okay, I paused the recording to check on something. This was badly written and it was a mistake. For that is divisible by 7. It's really double the last digit and subtract it from the number, the original number. And then compare it, subtract it from the rest of the number. In other words, the number that's formed by all but the last digit. If we subtract that doubled amount from the rest of that number, then if that answer is divisible by 7, the original number will be as well. Let's look down here. We pick 112. 2 is the last digit. We're going to double that to 4. If we subtract it now from 11, which is the remainder of this number, result of 7. Let's look at a number 1414. We know that since 14 is divisible by 7, it's 2 times 7. We know this number is going to be divisible, but let's check it. So 4 is the last digit. We double that to 8. Now we subtract it from the rest of the number, 141. The result is 133, which, if you pull out your calculator, is 7 times 19. So it's divisible by 7. I'm going to add a title and add that slide to this presentation. Okay, so there is where we are now. Okay, I think I lost when I tried to record that. So I think I actually did not have this showing. So here it is, 112 subtract 4 from 11, which is the remainder of 112, we get 7. 14, 14, double the last digit of 4 to 8, we get, subtract that from 141, we get 133. So that is divisible by 7. Let's do some examples here of prime factorization. First off, when we factor, I'll go over this in class and show you a little table that can make it a little faster. Every number that is even, of course, you start by dividing by 2. You start with the lowest prime number that divides into the number. In this case, it's 2, so 2 times 48, okay? So if we divide 48 by 2, we get 24. If we divide 24 by 2, we get 12. If we divide 12 by 2, we get 6. If we divide 6 by 2, we get 3. That's how we get 2 times 2 times 2 times 2 times 3. 52 is an even number. Divide 2 into 52, you get 26. Divide 26, that's even by 2, you get 13. 13 is prime. That's where we end. 69, the last digit's divisible by 3, therefore the number is divisible by 3. 3 into 69 is 20 and is 23. 23 is prime. 42 is an even number. 42 divided by 2 is 21. 21 is 3 times 7, so we got 2 times 3 times 7. Okay. So we can do some practice. 60. 60 divided by 2 is 30. So we've got 60, we've got 30. 30 is divisible by 2 into 15. 15 is divisible by 3 with 5 left over, so it's 2 times 2 times 3 times 5. 48 we just saw. 75 ends in 5, therefore it's divisible by 5. So we have 75. We have 5, and then 15 is what is 5 into 75. And again, 15 is divisible by 3 to get to 5, and 5 again is prime. So we have 3 times 5 times 5. By custom, we list it in numerical order of the prime factors. 72 divided by 5 is 36, or divided by 2 is 36. Divided by 2 is 18, divided by 2 is 9, divided by 3 is 3. So we've got 2 times 2 times 2 times 3 times 3. Okay, so you can practice on some of those. Greatest common factor is a process by which we do a prime factorization for each number. Find all of those that are common to both and multiply them together. So we will do these in class on Wednesday, but the way we do this is we set up a prime factorization. If we do a prime factorization, I'm just going to write on here. If we do a prime factorization of 48, it's going to be 2 times, and that's 24, divided by 2 is 12, divided by 2 is 6, is 6 rather, divided by 2, or divided by 2 is 3. So 48 is 2 times 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. Go over here to 60, we just did that. We've got 2, and that's 30, times 2. That gets us down to 15, times 3, times 5. 2 times 2 is 4, times 3 is 12, times 5. So what we have is 2 2s and a 3. So the greatest common factor is 2 times 2 times 3, which equals 12. And you can do the same with these. I would like you to do these and bring them in as a little homework assignment so that you get, so that I know you actually did this. So find, using this method, and read your text, find the greatest common factor of 21 and 75 and the greatest common factor of 24 and 35. Now, sometimes the greatest common factor is just one prime number. So if that's what you find, then that's fine. Okay. I don't think that's going to be the case with any of these. Okay. So we'll do one more of these here. Greatest common factor of 42 and 70. So 42 is equal to 2, and then 21 is the next one, times 3 times 7. Okay. And then 70 is equal to, it's an even number. It's also ends in 0. Since it's an even number, we're going to start there. 2, and then 35 is the next one. So 5, we know that that's the case, times 7. Okay. So we have here 70 is 2 times 5, which is 10 times 7. All of these are prime numbers. So the greatest common factor is equal to the commonalities here, 2 and 7. So it's 14. So go ahead and do these as well. The least common multiple is the smallest whole number that both numbers divide into in the problem. Let's take a look at that. You create a prime factorization. In the prime factorization of the larger number, cross out any factors that are duplicated in the smaller number. Multiply the smaller number by the remaining prime factors of the larger number. Okay, so let's take a look at how that is done. The lowest common multiple of 3 and 4. Okay, we have prime factorization of 3 is 3 and 1. Prime factorization of 4 is 2 and 2. Okay, so if we go back up here, multiply the smaller number, cross out all factors that are duplicated in the smaller number. There is no least common multiple. Okay, there is none. So the smaller number has, or actually that's not quite true. The smaller number by the remaining prime factors of the larger number. If we cross out any duplicates in the smaller number, well, there aren't any. So actually, the least common multiple in this case is going to be 12. 3 times 2 times 2, because there are no other factors. 12 and 21. If we look at 12 and 21, the prime factorization of 12 is 2 times 2 times 3. And of 21 is 3 times 7. Okay, let's go back up and look at the rule here. Cross out any factors that are duplicated in the smaller number. Okay, so we go down here and we find the smaller number has a 3 in it. So we actually are going to cross out the 3 like that, and we will cross out the 3 over here. Okay, so that gives us 2 and 2 and 7. Okay, or 4 times 7, which is 28. Wait a minute. Multiply the smaller number, excuse me. So 7 times 12, rather, is 72. 7 times 12. 5 times 12 is 84, rather, is 84. See, I told you I had to check my numbers. So 84 is the lowest common multiple. Okay, let's do one more because this is such a screwy concept. 24 is 2 times 2. That's 4 times 2. Okay, we've got 8 times 3. Oops, back up. 3. And 44 is 2 divided into 24 gives you 22 times 2 times 11. So we look at the smaller number and we cross out 2 of these 2's in the larger number. There are some duplicates here, so we get rid of those. So let's put our little cross out in. Okay, so now we have 11. 11 times 24 is 240 plus 24 is 264. That's the lowest common multiple. We can check this by division. 24, we can divide that into here. We can do that on your calculator. You can check me on that. Okay, here's some practice. Go ahead and do some of those. Okay, I'd like to move on to adding and subtracting integers. There's a couple of things. If we look at what we call a number line, starting at 0, we're going to assume there's a 0 right here. And in fact, I'm going to put that in. Okay, there's a 0 right here. Number lines increase in value from left to right. The 0 can also go further left into negative space, so we can go the opposite direction. So if we're going to add numbers, we've got 3. We put the first one. We started off 1, 2, 3. Start at 0. And now we want to add 5 more to get to 8. Now you all know that, but this is the number line theory for it. But let's look at what happens if we add negative numbers. We're adding -1 and -2. When the sign of the number is is negative, we're moving, instead of to the right, we're moving to the left from 0. So we got -1, so we start at 0 and go left 1. -2, we go 2 more spaces to get to -3. Okay, so we can subtract a negative number. Now, here is what happens. This, again, is an implied multiplication. The implication here is that this is -1 times -5. Math uses a lot of implications and a lot of understood conventions. A negative times a negative is a positive. So now we are at -3 plus 5. So we start at 0, move 3 to the left, and then starting there, we move 5 back to the right to come up with 2. Because minus a minus is a positive. Now, plus a plus is not a negative, so don't ever make that mistake. Okay? So if we think about that, if you have $50 in the bank and you spend 75, how much do you have left? Well, you start off at, we're just going to take a 0 point here. We spent 50. So we know that we had 50 to start with. Now we have spent, debit, spent minus 75. So we're $25 in the hole, along with a big overdraft payment. So examples, 17 minus 10 is 7. 5 minus 12 is -7. -6 minus 7 is -13. Okay, so this is 7. This is -7. This is -13. And this is -6 minus a -7. So this is equal to -6 plus 7, or equals 1. -5 minus a -3 is going to equal 5, rather. 5 minus a -3 can equal 5 plus 3 equals 8. I hope this is all making sense. Okay. Let's go down one more. Here's your practice. Go ahead and practice on those. We'll ask for your solutions in class on Wednesday. Again, don't forget that minus times a minus is a plus. Here's a little fooler. Plus a -3, that equals 5 minus 3. Don't be fooled by those things. Okay, so when multiplying and dividing integers, a negative times a negative is always a positive. A positive times a positive is always a positive. Dividing a negative by a negative is a positive. And dividing a positive by a positive is a positive. If we are multiplying or dividing a negative and a positive, the answer is always negative. So if we have a negative times a positive, it's a negative. A negative divided by a positive is negative. A positive times a negative is a negative. And a positive divided by a negative is indeed a negative. So if the signs are the same, it's a positive answer. If the signs are opposite, it's a negative answer. Okay. Let's go back to the slideshow so we can do these. Algebraic expressions such as 3x, 5y, 7xy, which means 7 times x times y, or -4 times a, are all called terms. The variables in the terms are The term literal factor you're going to run into. And literal just refers to the fact that it is a letter, not a number. The number is called the numerical coefficient. Learn this word. Terms that have the same literal factors are called like terms. So 3x and 5y are not like terms. Let's go down. We can only add or subtract like terms, terms that are the same. So what we do for something like this is we're adding and subtracting the numerical coefficients. 3x plus 5x is 8x. Or subtracting. 10y minus 3y equals 7x. 4a plus 1b minus 2a plus 3b. We group it, regroup it here. So we say 4a minus 2a is 2a, and 1b plus 3b is 4b. So, excuse me. So here's a couple of examples. And so I'm going to get out of the, so we have 7y plus 12y is 19y. 3xy, now see, we have x times y, and it does not matter if this is xy or yx. Multiplication is what we call commutative. It doesn't matter which number is multiplying the other, you're going to get the same answer. By convention, we put the numerical coefficient on the left. Okay, so 3xy minus 10xy is minus 7xy. So 6a plus a plus b plus 5b plus 6a is going to be, let's look at, that's not a minus sign, I don't want that. Okay, so it's going to be 2a plus a plus 6a plus b plus 5b equals, now we simply add up the like terms. 2a plus 1a, if there's nothing, if there's no numerical coefficient, we assume it's 1. 2a plus a is 3a plus 6a is 9a, whoops, a, plus b plus 5b is 6b. So that's how that one works. So you can do the, you can see the examples there. So let's go back to our thing. Right, add some numbers, rational numbers. We have real numbers and we have rational numbers. Real numbers, rational numbers are anything that can be expressed as a fraction. Fraction has two parts. The top number separated by a line from the bottom. The numerator is the top number. The denominator is the bottom. When we multiply fractions, we multiply numerator times numerator and denominator times denominator to come up with this. So we multiply straight across. When dividing, what we do is keep the first fraction. This, remember, this is a over b divided by c over d. So we have to change the multiplication by flipping the second fraction. In other words, we do the inverse of the second fraction. D over c is opposed to c over d. So now we have a multiplication and the answer becomes, oops, and the answer becomes AD over BC. Okay? Adding and subtracting, if the numerators, the denominators are the same, we add or subtract the numerators. Simple. If they're different, we have to find what we call the common denominator. The easiest way to do that is simply to multiply the two denominators together and cross multiply from the denominator of one fraction times the numerator of the other. So in this case, we got AD plus BC over BD. No, none of the numbers are the same. So remember, this is the easiest way to find your common denominator. Okay, so we calculate lowest common denominator, or lowest common multiple, to find a common denominator. We don't need the lowest common multiple because we'll reduce it later. But we've got B times D. We just multiply them. Okay, so here are some examples. And again, I'm going to escape out and do some of these. So now we have 2 times 9 is 18 times 15 is 270, I believe. 18 times 15, yeah, 270. Okay. It's not going to let me write on this. 270, it's not going to do that. Divided by 3 times 10 is 30, times 16 is 480. So 270 divided by 480 is the same as 27 divided by 48. Okay, which is the same as 9 over 16. Okay. Now, remember, this converts now to 3 over 2 times 3, or 6, and 4 over 6. So 3 plus 4 over 6 is 7 over 6. Here, we invert the divisor, the number doing divide. Remember, this sign says divided by. So now this becomes 3 over 4 times 8 over 9, or 24 over 36, which is also 2 over 3. Okay, so you can do some practice with these. And remember, this means divided by. Okay, and we have to convert these. And don't forget how to multiply. Okay, an exponent. This is another term. You remember this from the PEMDAS, the second term was exponents. Exponents simply mean it's a number of times that we repeat multiplication. So if we see an exponent like this, 3 to the 6th, means we line up 6 3s in a row and just multiply them. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is 729. 2, when it's a 2, we call it squared. And it's just 7 and 7 multiplied, that's 49. 3 we call cubed, and we don't really have anything past this. So this is 3 to the 6th. We have x to the 3 is x cubed, that's x times x times x. Fractions can be done as well. But remember now, 1/2 to the 4th power is 1/2 times 1/2 times 1/2 times 1/2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1/2 to the 4th power is 1/16. Okay. So let's look at translating between English and algebra. So x plus y is the sum of x and y. Remember, the sum is what happens when you add. X minus y is the difference of x and y. Remember, difference of x and y. In general, we're going to say difference of x and y means x minus y. Okay? The product of x and y is when we multiply. And here we 3 less than x, or x minus 3, or the difference between x and 3. Now we have 5 times x divided by y. Also can be stated as 5x over y. And here we have 9 minus the product of x and y. Now here's how we think about parentheses. 4 times the sum of w and 2. And that's the end of the slideshow. So let's go back to, no, that's not what I want. Where is it? All right, let's just escape out of here. And we'll come back to here. And now we'll share. Come back to the course modules. All right. So again, your chapters are here. It's online. Read it. You can download it as well, and just store it on your computer for use during the class. Look at after you watch this, I want you to send me an email through Canvas to your instructor. It's easy to do. Send an email to me. And in the email, I want to have you put in the word, Paris, P-A-R-I-S. So put that in the email. That will tell me that you've watched it. Do some of those examples and be prepared to review them in class on Wednesday, in which case, and here are the readings and tools. Again, you're looking at chapter 1 and chapter 5. And you can begin this assignment if you like. We'll talk about that more on Wednesday. So I hope you have enjoyed your holiday, and we're done with this class. And thank you for listening.